Hello, everyone. Thank you for joining our webinar, Optimize Container Workloads with EC2 Spot. This is the second webinar of the series. For those of you that were there for the first one, welcome back. My name is Aparajita Jas. I'm a Senior Business Development Manager in the EC2 Spot go-to-market team. With me, I have my co-presenters, Pritam Pal and Sandeep Palavasa, who are specialist solution architects in the AWS Spot go-to-market team. Some housekeeping items before we start. The session is for 2 hours with Q&A at the end. But if you have questions during the presentation, please feel free to type and ask in the chat window. We do have team members present who can help answer. You will be on mute by default until we get to the live Q&A at the end. This is the agenda for the session. I will give an overview of Spot covering the fundamentals and best practices, followed by an introduction to the AWS Container Services landscape, and then some customer stories for successful Spot adoption that demonstrates why Spot is such a great fit for container workloads. Pritam and Sandeep will then go into the details of implementation of Spot with containers, along with showing a demo of Spot with ECS and EKS. And then, to keep things interesting, we have a short quiz, which also has Amazon gift cards as prizes for the top 3 winners. I promise you it's going to be fun, so please stay till the end. Finally, we'll open it up for live Q&A. EC2 Spot is one of the 4 ways of purchasing compute on AWS, the other 3 being on-demand reserved instances and savings plan. Spot is the most inexpensive and flexible way to access EC2 instances. What Spot is spare on-demand capacity that is available for up to 90% off the on-demand prices. The infrastructure for Spot is the exact same as on-demand and RIs, with support for the same number of 89 security standards in 25 regions and over 300 plus instances. Spot helps you reduce cost on existing workloads, migrate new workloads to the cloud without increasing your infrastructure budget. This particular aspect is all the more relevant given where we are today with the pandemic raging and adapting to life in this new normal. So at the end of the day, with Spot, you can reduce your time to market, extend your runway, and build for scale. You can quickly ramp up massive data analysis jobs or optimize the resilience of your web-based applications. You can throw more compute at your needs, get faster results, and accelerate innovation. Here are the 4 simple rules to remember for Spot instances. Even though it is the exact same infra as RI and on-demand, unlike RI, it does not require making a commitment. It is also the only way of getting the deepest discounts on EC2. It is spare EC2 capacity that you can acquire by paying by the second for Linux instances and by the hour for Windows instances. Let's move on to pricing. Spot pricing is a function of long-term supply and demand. The pricing is simple because it does not change often and is typically an average discount of 70% and up to 90% off of the on-demand price. To simplify the purchasing experience, we eliminated the bidding model 2 years ago. This change has made it a lot easier to get Spot instances because you no longer have to think about a bidding strategy. So Spot is spare capacity on EC2 and the only way to get the deepest discounts. What is the one thing that we need to remember? Well, Spot is an interruptible service. If we have a spike in request in our on-demand space, AWS reserves the right to reclaim that capacity in the Spot market with a 2-minute notification. That is why you see here at the bottom that the best workloads for Spot are fault-tolerant, flexible, and stateless. Last and the most important rule to remember about Spot is to diversify. What we mean by diversification is having the flexibility to use multiple instance types, sizes, and availability zones for your workloads. That is the only sure shot way to being successful with Spot long term. This explains diversification in more detail and introduces the concept of what we call a Spot capacity pool. As you see here, C4 is the instance family, L to 8XL are the different instance sizes, and 1A to 1C are the different availability zones. A combination of an instance family, size, and availability zone in every region is an independent Spot capacity pool. Now, if you could use a C4 4XL in 1A, suppose, can you also think about using a C5 4XL or a C4 8XL in 1A to run your workload? You likely could. When you specify those three, each one of those are different capacity pools. More of those you specify, the better are your chances of requesting, acquiring, and maintaining your Spot target capacity. The reason why it's important to have flexibility is that Spot is paired on-demand capacity. So there may be times when there is a spike in demand for a particular instance type in an AZ, and it becomes unavailable on Spot when we reclaim that particular instance in that AZ. But if you have flexibility and have specified additional capacity pools, then it increases the total pools of available Spot capacity that can be utilized for fulfilling your request, and therefore minimizes the overall impact of losing some of those instances. Autoscaling groups can spin up other instances from capacity pools you specified in your configuration to maintain the target Spot capacity that you desire. So to summarize, when you diversify, you increase your resiliency to interruptions. Revisiting pricing here one more time. If you heard about Spot instances prior to November 2017, you may recall that the EC2 Spot pricing was based on bidding. Instances were priced based on customer bids, which made pricing difficult to predict and Spot availability more volatile. That is not the case anymore. With the current model, Spot pricing is based on long-term supply and demand. At any point, you are paying the market price for Spot. This has really simplified the pricing and consumption model. It has made the price points a lot smoother, not spiky anymore, as you see here in this graph prior to November in 2017. And there are no longer a lot of fluctuations throughout the day that it used to be. Prices can change slowly over time. Take a look at the 90-day price history API from your console and see for yourself that the price points are really stable these days and a lot more predictable. There could be slight fluctuations like you see here, even in different availability zones, which is a function of supply and demand. But overall, the prices are a lot more stable. Interruptions are an important thing to understand when it comes to Spot, because Spot by nature is an interruptible service. You want to make sure that you're putting the right type of workload on Spot. You don't want to put workloads that are stateful or long running. Putting a database on Spot is a really bad idea. Now, what actually happens when we need to reclaim an instance is that we will give you a 2-minute warning, either through a CloudWatch event, or you can pull the metadata on the instance, and you have 2 minutes to take action and gracefully move off of the instance getting interrupted and bring your workload up in another instance in your fleet. There are different strategies you can take to handle interruptions, and we will cover those in more detail in the next section. Next, I want to highlight what is on the left side here. The fact that interruptions don't actually occur that often in practice is what you see here on the left. Over 95% of Spot instances were manually terminated by the customer in the last 3 months because they completed their workloads, versus AWS coming and having to reclaim that capacity. So less than 5% of the times do we have to reclaim the capacity because we're seeing a spike in demand. This data is available on Spot Instance Advisor webpage. We will share this link later, but if you search for this in your browser, that's the first link that comes up. So while you want to be prepared for interruptions on Spot, and you do want to put the right type of workload on Spot, know that interruptions don't actually happen in practice that much. And then there are different ways to handle interruptions within the 2 minutes after you get the notification. Last but not the least, one common question we get from customers is, does Spot have enough available spare capacity to support customers? Well, as you see here, anecdotally, what we like to tell our customers is that customers are using more compute capacity on EC2 Spot instances every week than customers were using in all of EC2 in 2014. So continuing on the last statement that I made. Here is a case study that illustrates that. We have customers regularly spinning up 1 million vCPUs in a single cluster out of a single region. Western Digital is one of our successful customers that spun up a cloud-scale high-performance computing cluster on Spot. They ran over 2.3 million simulation jobs on a single HPC cluster of 1 million vCPUs built using EC2 Spot Instances. Now, as you see here on the right, they were able to do this successfully because they diversified well. They are using or they're dipping from multiple capacity pools to get the target capacity that they desired. The time to results went from 20 days to 8 hours, again highlighting how effective Spot could be to scale within budget, get faster results, and reduce the time to market. So I talked about putting the right type of workload on Spot. Now let's discuss the specifics of what those are. At a very high level, this is where we're seeing the greatest adoption of Spot today. Anything containerized is a good target for Spot because containers by nature are loosely coupled and fault tolerant. We like to say that containers and Spot is a match made in heaven. Other areas where we are seeing a lot of traction for Spot is big data analytics, CI/CD, stateless web services, and high performance computing. Big data and HPC workloads really benefit from the scale that Spot instances can provide. The list that you see here doesn't need to be considered an exhaustive list. As I mentioned, any workload that is fault tolerant, flexible, loosely coupled, and stateless will be a good candidate for Spot. If it is outside of list but has all the attributes that I mentioned, it is a good idea to put that workload on a Spot instance. So as you scale your cloud environments and usage, you need to optimize your costs, and correctly scaling becomes a very critical aspect of your strategy. You can use RI and savings plan with on-demand and Spot instances. This helps you fix or mix our pricing models to best match your utilization and optimize your performance and costs. EC2 Fleet and auto-scaling groups allow you to combine all the different purchasing options, Spot, on-demand, RIs, and savings plan. You typically use RI and savings plan for known steady-state workloads. You scale using on-demand for new or stateful spiky workloads. And then you scale using Spot for flexible, fault-tolerant workloads. A database, the bar here on the extreme left, needs RIs and savings plan because it is stateful. A managed machine learning training job on SageMaker on the extreme right, like this bar here, can be run entirely on Spot. However, an EMR workload, the one here in the middle, can be run on a combination of purchasing options, master nodes on RI or OD, core nodes on on-demand, and task nodes entirely on Spot. There are a large number of customers taking advantage of Spot today. Spot has continued to grow and evolve every day as we have simplified the pricing model, created more automation tools, and launched the integration of Spot with various AWS services. The top section here shows the integrations with auto-scaling groups, Amazon EMR, EKS, Batch. We learn more about the EKS and ECS integrations today. We also support integrations with other ISVs that you see here at the bottom for all the different workloads that I talked about earlier. Jenkins for managing CI/CD pipelines, Kubeflow and Databricks for big data workloads, Kubernetes and Docker, like self-managed Kubernetes and Docker for containers and so on. The goal for AWS is to make Spot as easy as possible for customers to start using within their existing workflows. And you will continue to see that investment going forward. Now let's talk specifically about containers. Containers, as I mentioned, are often stateless. Oh, what just happened? All right. So containers are stateless, flexible, and fault tolerant, and therefore a great match for Spot. We have integrations with both ECS and EKS, and also have many customers who are running self-managed Kubernetes clusters on Spot. What Spot provides is a way to scale your clusters and not impact production while reducing your cost. Skyscanner is a perfect example here. If you're not familiar, they are the Kayak or Expedia of Europe. They recently migrated their Kubernetes production workloads to Spot, and as you can see here, they are now tracking about 74% in savings across all of their regions. They had a pretty drastic impact to their compute cost by taking advantage of Spot. At the bottom, you see other familiar names for customers that are successfully using Spot for container workloads, such as Lyft, Expedia, BL. Reasons here is an interesting one. They are a Singapore-based startup. They allow customers to search for items using images instead of keywords. They are orchestrating their Spot instances via EKS to manage and scale more than 20 specialized microservices in processing millions of images in an hour. Spot has enabled the startup to extend their runway and grow much faster. They have been seeing over 200%. All right. They have been seeing over 200% growth year over year since they have started adopting Spot. Here is another success story about Telecoming, a Spanish ad tech company that develops technology to monetize digital services. To monitor web and mobile applications using a real browser environment, they leveraged ECS on AWS Fargate. They also decided to adopt Fargate Spot. Fargate Spot is a new capability on AWS Fargate that can run interruption-tolerant ECS tasks at up to a 70% discount off the Fargate price. With a goal to optimize cost in infrastructure as they scaled, Telecoming launches about 30,000 tasks a day, measuring 70% savings compared to previously used AWS Fargate. The current AWS container services landscape covers a broad set of products. At the management and orchestration layer, we have ECS and EKS. ECS is our homegrown orchestration service, which many customers find easy to use because of its very familiar AWS APIs and controls. EKS makes it easy to deploy, manage, and scale containerized applications using Kubernetes on AWS. You can run your containers on ECS using either the EC2 launch type, where customers have to provision and manage the underlying instances on which their containers are running, or they can choose to run their containers in a serverless manner with the AWS Fargate launch type. Since reInvent last year, this is also now true for EKS. Customers can launch their Kubernetes pods using either the EC2 or the Fargate launch types. We also provide a registry service, Amazon ECR, where customers can store their container images. Additionally, we provide two application networking services that you see in the top here. AWS Cloud Map, which does service discovery, and AWS App Mesh, which is a managed service mesh. With containers, AWS provides its customers choice. We have ECS and also EKS, our own managed Kubernetes service. When customers want to run containers in a cost-effective way, ECS provides out-of-the-box Spot instance integration. With Fargate Spot for ECS, customers can run containers in a serverless manner. You just need to bring your Docker files and tasks and run them with ECS. Now, with the launch of Capacity Provider after reInvent 2019, we moved to application-first approach and away from the infrastructure-first approach. In the Kubernetes world, EKS makes managing nodes easy in a way never done before. You can, like I mentioned before, you can now run EKS pods in a serverless manner with EKS Fargate. EKS runs upstream Kubernetes and is certified Kubernetes conformant, so you can leverage all benefits of open source tooling from the community. You can also easily migrate any standard Kubernetes application to EKS without needing to refactor your code. Given the choice, a lot of customers choose to run Kubernetes on AWS. In fact, this may surprise you, but AWS has the most number of customers running Kubernetes in the world, with 50% of all Kubernetes deployments running on AWS, according to the Cloud Native Foundation. This is entirely organic growth fueled by strong community of developers, customers, and partners. EKS supports managed node groups, which means that the control plane is fully aware of its nodes and can manage them. We have seen customers increasingly adopting EKS with Spot instance-based node groups. ECS, Amazon ECS, is a fully managed container orchestration service. Customers such as Duolingo, Samsung, GE, and Cookpad use ECS to run their most sensitive and mission-critical applications because of its security, reliability, and scalability. ECS has grown rapidly since launch and is currently launching 5x more containers every hour than EC2 launches instances. ECS is a great choice to run containers for several reasons. First, you can choose to run your ECS clusters using AWS Fargate, which is a serverless compute for containers. Fargate removes the need to provision and manage servers, lets you specify and pay for resources per application, and improves security through application isolation by design. Second, ECS is used extensively within Amazon to power services such as Amazon SageMaker, AWS Batch, Amazon Lex, and Amazon.com's very own recommendation engine. What this means is that ECS has been tested extensively for security, reliability, and availability. Additionally, because ECS has been a foundational pillar for key Amazon services, it can natively integrate with other services such as Amazon Route 53, AWS Identity and Access Management, and Amazon CloudWatch, providing you a familiar experience to deploy and scale your containers. ECS is also able to quickly integrate with other AWS services to bring new capabilities to ECS. So that brings me to the end of the overview section, and I will now transition it over to Pritam to go into the deep dive with containers.
Hey, thank you, Aparajita. Let me share my screen. No.
I'll stop sharing.
Okay, let's try. Okay, do you see my right screen?
Yes.
Thank you. Okay, I am Pritam. I am Senior Solution Architect with EC2 Spot team. With me today, I have my co-presenter Sandeep, who will run the ECS demo for you later in this session. So what makes AWS the best place to run containers? 80% of all containers in the cloud runs on AWS. Customers such as Samsung, Expedia, KPMG, GoDaddy run their containers on AWS because of our security, reliability, scalability, and cost efficiency. So today we'll focus on four of the subjects here: Amazon Elastic Container Service, ECS, Amazon Kubernetes Service, EKS. Then we'll also talk about the hosting services that we have like EC2 and Fargate. The focus will be to go through the tips and tricks, how you can save tons of money using our Spot while running containers for your workloads. What I assume that our audience today have basic knowledge of containers like Docker and some experience with any container application or hosting services like ECS, Kubernetes, or EKS. So we'll start with ECS actually today, and then we'll go through how we make things cost efficient for you. So while coming to cost, right? So to save on compute cost, we must know how compute cost is calculated. So the cost is nothing but the number of compute unit multiplied by the time you use them, and then cost per unit. Now the compute unit can be EC2 instances or it can be Fargate. So the goal would be to minimize our cost while keeping the performance goal steady. And we'll take them one by one. Now the big questions are, how much compute you need? Do you need 100 instances? Do you need 200? Do you need 400 or 1,000? And the second question is that how you choose your right type of instances. Now with AWS, you know, we have got more than 300 type of instances choice. So which is right for you? Do you need a C or a M or a P3DN or a D4? What are they and how they map to your workload, right? And when you talk about the Fargate, things are really simpler because there's no server to manage. You just choose your task and pod size and then choose purchase option like Fargate and Fargate Spot. So the first thing is that you choose the right kind of compute unit and you choose the right type of instances. The second would be that you run them at the right number. It's a second dimension you can call. So think about this. Do you really keep your lights on when there is no one at office? Same goes with instances, right? You don't need all of them all the time. So how do you scale? If you're using ECS or EC2, you can just use cluster auto-scaling. Or if you're using Kubernetes or EKS, you can use something called cluster autoscaler. We'll deep dive here as you go more. So the third thing is that how you maximize the price performance with 100% spot. We can call it the third dimension or the purchase type. As you have shown, you have seen earlier, we have got 4 purchase types here, how you buy compute power on AWS. We have got reserve instances, savings plans, on-demand, and spot. Now you can think about where you want to run your workloads depending upon what kind of purchasing model you want to buy depending upon your workload. Now there are few workloads which you can run 100% on spot. Think about the ETL jobs, the big data workloads, the worker nodes for containers, the CI/CD processes, the dev test environment. And what we've seen that there are many workloads where we are seeing largest spot adoption, especially with the startups. Startups typically are tech savvy and they love data and then end up dealing with lots of data and lots of containers. So if your workload is something that similar seems to you on the picture in left, then we can say you are going to save lots of money by implementing Spot. So that was the basic how Spot and the container works hands in hand together. Now talk about ECS. Like I mentioned before, our philosophy with containers in general is that make things easier for our customers so that you can focus on the stuff you really want to do and serve your end customers. That's why we developed ECS. ECS, what we call elastic container service, which is highly scalable and it is fast, it is secure, and it is easy to deploy. You just need to bring your Docker containers and you start with that. So what we have done, we have always believed that everybody should have the right tool for their work. That's why we have developed an infrastructure. We have developed something called an application first approach, where the infrastructure reacts to the need of application. That means if different parts of your application has got different scaling needs, the infrastructure reacts to that. That means if we have got two components, A and B, A has got a different scaling need from B, then the scaling need should be catered in that manner. You may have an application that is good to run on Spot, but you may have a long-running application that is not fault-tolerant and may not be suitable for Spot. So how you control them, how you divide your infrastructure in a manner that your application can take the best benefit out of it. So we'll talk about application-first architecture as you go forward. Think about this. We have built something which tracks your users actually, and it grows and shrink as needed, and it happens automatically. Now the good thing is that the scalability is applicable to the purchase choices you make. With ECS, you have the choice to run your task on EC2 boxes or instances or on Fargate. And then you also have the choice of purchasing options, like you want to run an on-demand and an on Spot. Now the logical question arises, why then not everybody running on Spot if it is 90% cheaper? Okay, so Spot, as you know, is an interruptible service, and it's a spare capacity which can be taken away with 2 minutes notice. And this happens on average 5% of the time. which means very long running workloads like database are not suitable to Spot. So are the application which saves their data, their session data inside the EC2 box. But for the containers, the good thing is that what we have seen, majority of workloads are fault tolerant and loosely coupled, which makes them the right choice to run on Spot. So take an example here. On my left-hand side, I have an application which is served by a load balancer and several EC2 boxes. I have this is part of auto-scaling group, and I also have a CloudWatch alarm to see what is the need and not. And I have a graph here, which is time versus load matrices. So as the load is stable, I am running, let's say, 6 units of compute, and the load grows, and I keep increasing my compute need as the CloudWatch asks me to do. Now you'll be seeing there's a significant lag of performance because it takes some time to react, right? As the load grows, the EC2 box understand, okay, the autoscale group understand we need more boxes. It takes some time, which may not be suitable for your workload. Think about some need of gaming need or some fast processing sites where people come and go all the time, right? So one option is that you over provision your infrastructure by some percentage, maybe 30, 40, 50%, so that your laggings are gone. There's no performance gaps. Now, what that means too, you're running on too many compute capacity, which are mostly not needed, and you are paying the cost for it. Here comes Spot. So one option would be is that run the spill capacity or the extra capacity that you think you would be needing on Spot. So in this case, what we are doing, we are running the additional capacity, which is like, let's say, 50% of our provisioning part on Spot. Now there's no performance cap. We are always stuffed with compute, and how much it will be costing. So think about this. This 1/3 would be giving you 50% more capacity. But think about this compute also comes at a cost which is like 70% cheaper or 80% cheaper than this compute price. So ultimately, you'll be getting this compute, this green portion of the compute at very cheap cost, which would be roughly between 5 to 10% of your total compute cost for the whole application. This is the easiest way that customer we have seen they introduce Spot without changing anything much at their end. There is no risk to take it forward because you already stuffed high with your on-demand and you're only scaling the peak with your Spot. Now, how you control that? So we have got mix of Spot, mix of on-demand. So with capacity provider, which we call the missing link, actually, we can control how you want to put your services on Spot and on-demand. So it may happen that you don't want whole of your service B to put on Spot or whole of your service A to put on like capacity provider 1, which is like, let's say, on demand, and the BS2 is a Spot, right? So we have something called capacity providers where you can give different kind of weight option. So for example, I can say that for my service A, put a weight of 2:1 so that out of 6 tasks, 4 tasks go to this ASG and 2 tasks go to this ASG. This can be on demand, this can be Spot, like this. So you can choose what are your options actually. It's a multi-tenant for each service. You can have their different mix. You can scale them independently, and you can put your capacity at the ASG level, so you can control what kind of instances you are using. That gives you lots of choices actually to start with. Now, if you think it's too much for you to handle, you don't want to handle anything. You are like a developer. What matters for you is that your app should be up and running. So you have something called ECS Fargate and Fargate Spot. So think about this. We had this EC2. We have the EC2 actually, and then we created ECS, the container service. Then we created Fargate. So for Fargate, you can think the container in the cloud. There's no server to manage. What it looks like is that when you use Fargate, you just pay as you go. You don't have to think about what will be security and compliances, what will be the scaling portion, how much system administration you want. You just bring your task, your Docker containers, and you run them. Think about this. This is the standard Fargate task definition where you have got a task called my task, and you say, okay, I need 1 vCPU and 2 GB memory and blah blah blah, and that's done. Okay, and under that you have the container, and you give a specification like image for the container and how much memory reservation you need it, and that's all you need to run your task on Fargate. Now Fargate also gives you 50 different options, like starting from 0.25 vCPU to 4 vCPU and 0.5 GB to 30 GB of RAM options. Now with Fargate, we have something called Fargate Spot, which is again the unused capacity of Fargate, like EC2 Spot capacity, and you get 70% off from the standard Fargate prices. And it also can be, the task can be claimed with a 2 minutes warning. And in Fargate, you have the automatic diversification that you do in-house actually. If you want to know about the Fargate pricing, you can go to the Fargate ECS Fargate pricing page, and you'll be seeing 2 pricing options like Fargate and Fargate Spot, where this price is almost fixed and this price keeps on changing. So this is a screenshot taken from some time back. So this prices may go a little bit up and down based on that. If you calculate on an average, this is 70% cheaper than this price. And that makes a Fargate a whole big differentiation factor brings to the market, because you are getting compute at a very, very cheap cost actually. And that opens up for lots of people to use Fargate Spot going forward. So with that, what I'll do, I'll hand over to Sandeep, who will be showing you a nice demo and how you can just start using ECS with just a Docker file or your container specs and run them on both you call EC2 and EC2 Spot instances. And I'll come back again with the Kubernetes part of the world and a small Kubernetes demo. Over to you, Sandeep.
Thanks, Pritam. Let me quickly share my screen before I get started. Can you guys see my screen all right?
Yep.
Awesome. This is Sandeep. I'm a specialist solutions architect for EC2 Spot 2. I work closely with Aparajita and Pritam as well. So what I'm going to show you today is a demo of how you can run your microservices in ECS and also use different purchase options and launch types that we just showed you, which is EC2 Fargate and also Spot and on-demand, and how you can mix and match and run your service, right? So for that, as a sequence of steps, what I'm going to be doing is quickly show you how to set up an ECS cluster and how you can create ASGs which can get you EC2 Spot and on demand, and then add them as capacity providers, and then create your services to run on those capacity providers. And also we'll see how we can do the same on Fargate using Spot and regular Fargate as well. So to quickly get started, I'm gonna jump onto my console and go to ECS, which is Elastic Container Service, and create a cluster. So I'm going to be going to clusters here and quickly create a cluster. I'm going to be using the networking only option, just so I will be adding my ASGs later, and all the other configurations and integrations I'll be adding later. So I'm going to go ahead and hit next. And for the cluster name, I'm just going to be using as ECS Spot demo, and I won't be creating a VPC as part of this cluster because I already have a VPC that I'll be using for this demo. So I can enable the container insights, which will give you monitoring and troubleshooting mechanisms for your microservices, which are running in ECS, right? I'm going to be enabling that as well, and I'm going to hit create. So with that, we just create an ECS cluster, which is up and running, right? If you go and view the cluster, As you can see, the state is still provisioning. If I refresh, as you can see, the cluster is already up and running. So at this moment, we don't have any services or tasks running yet, which we will be scheduling in a minute. But when you go to a new tab, as Preetham mentioned earlier, the capacity providers, we already see 2 capacity providers that are already available here, that are Fargate and Fargate Spot, which comes default as capacity providers when you create a cluster. If in case you already have a cluster that was created a long back and you don't have these capacity providers, you can simply add them using a AWS CLI command. So now that we have our cluster up and running, let's go ahead and create our auto-scaling groups. So for that, I'm going to go to Services, and under Compute, I'm going to go to EC2. Right? So before I can create an auto-scaling group, I need to have a launch template. A launch template is a place where you mention all your launch configurations that is required for your instance to up and coming, things like Army ID that you want to use, security settings, network settings, things like that, right? So I'm going to create a launch template here real quick for our demo. I'm going to just name that the same as the cluster, but an LT in the end. So for the Army, right? So for you to be able to use these instances as part of your ECS cluster, you need to have an ECS optimized Army that is available for you to actually use. So you can create your own Army as well, but also Amazon provides you standard Army optimized for ECS that you can make use of. So you can find the Army IDs from the documentation of the ECS here. I'm going to be, for this demo, using Amazon Linux 2. And since I'm using the US West 2 region, I'm going to go ahead and click here to get that Army. So as you can see, this is just a parameter within the systems manager, which you can query via CLI, or if you're using CloudFormation, you can reference this using this path too, right? So I'm going to use copy that Army ID, and then I'm going to use that as part of my launch template. So if I search for that, got the Army, so I'm going to select that. So while I'm doing that, I will also go to instance types. For this demo, I'm going to just use a C5 large instance, which is one of my favorite instance types. So I'm going to use that. I'm not going to add any key pairs since I'm not going to be SSHing into any of these instances yet. So for the security group, I do have a security group that I created, which I will be adding as part of my launch template, which is configured to allow traffic that is coming from the load balancer and nowhere else. So, and also I'm going to keep everything as is. I'm not going to add anything else except the instance profile. I need an IAM policy which has right access to ECS to be able to use them as part of my ECS cluster, which I have created here, which I'll be using, right? And also, while these instances, since these instances need to go to ECS, right? So we need to bootstrap certain configurations for our ECS agent that will be running on these instances. So I'm gonna explain each of these things like ECS cluster, for example. We need to mention what is the ECS cluster that we want these instances to be attached to. So we will be setting those in the ECS config file, as you can see. Another important flag that we want to mention here is the enable spot instance training. So when you enable this, if there is an event of reclamation of your spot instances, there will be a 2-minute warning. So the agent, the ECS agent that is running on your instance will mark your instance into draining mode so that the tasks that are running on them will be rescheduled on any other instance that is available. So, and also parameters like container stop time is the time for which ECS agent will wait for the containers of the task to be run, shut down gracefully in the event of any spot interruption. And then after which it'll forcefully terminate the containers. So I'm going to enable all of those settings and put them into my config file, and I'm going to click create launch template here. So now we have our launch template created. So now let's go ahead and create our auto scaling groups. So I'm going to go to the auto scaling groups option here. So, and I'm going to create an auto scaling group here. So I'm going to create 2 auto scaling groups right now, one for Spot and one for on demand. I'm going to just name that ASG Spot, since I'm going to be doing this for the Spot instances, and use the same launch template that I just created, right? So, and I'm going to hit next. And we are going to be using the combined purchase options and instance type option, which is the mixed instance group option that you have for an ASG. We do that to make sure that we will be doing all the diversification that we just talked as best practices for Spot. So for this auto scaling group, I'm going to make this 100% Spot. And in terms of Spot allocation strategy, I'm going to be using capacity optimized. What this makes sure is it will launch your Spot instances from the deepest capacity pools that is available. So the more number of capacity pools that you give ASG access to by diversifying in terms of instance types, the better it can do the real-time decisions when you are scaling in or out. So when we talked about a diversification, we need to actually be flexible in terms of how many instance types we are flexible with our workload, right? So along with the primary instance, which is coming from our launch template, what I will be doing here is adding additional instance types. As you can see, we can be either size flexible or family or generation flexible. Which also will be ASG will be also giving some suggestions around here as to what kind of instances we can add here. So I'm going to take that suggestions and keep the 20 instances that it just suggested, which are very similar to what my primary instance is, and I'm going to use that. And in terms of network, as I mentioned, I have already created a VPC that I'm going to be using for this demo, which is ECS Spot demo. I'm going to select that, and then I'm going to run these instances in public subnets. So again, for a production environment, it's not ideal for security reasons to run them in the public subnet, but for this demo, I'm going to be running them on public subnet. I'm going to go ahead and hit next. I'm not going to be attaching any of the load balances here. I'm going to leave everything else default. I'm going to hit next. For the desired capacity, I'm going to be setting that to 0. So why I do that, and also I won't be setting any scaling policies here. The reason for that is we are going to be using these auto scaling groups as part of capacity providers under ECS and let ECS manage the scaling. What that means is the ECS cluster will be taking over all the scale in, scale out activities that needs to happen on the ASG. So that's why I'm going to set everything to 0, and I won't be adding any scaling policies here. I'm going to also enable scaling protection for my ASG instances, which is requirement for to be able to add this as capacity provider. I'm going to hit next. So, and also I won't be adding any of the notifications for this demo. And also I will be adding a tag called name, which is exactly same as the auto scaling group name for us to be able to see them on the instances, right? So I'm going to hit next for this. And then in the review, I'm going to go ahead and create my auto scaling group. So now that we have our Spot auto scaling group, I'm going to create another auto scaling group for my on demand as well. This time I'm just going to call it OD, and I will be using the same launch template that we just created as well. So I'm going to also use the combined purchase options here, but this time I'm going to make it 100% on demand. So since we are only using on demand, the spot allocation strategy here won't make any difference there, but I will still be flexible in terms of instance type, just because even in the on demand case, if first it tries to get you C5 large, if in case the C5 large is not available in the priority order that we gave, it'll try to get you the next available instance that is that you have. So it's always a good idea to have that in different options of additional instance types. So I'm going to use the same VPC again in the public subnet that I have, and I'm going to hit next. And again, I'm going to keep all of these default, decide capacity to 0, and let ECS manage my auto-scaling groups. And I'm going to select scale in protection. I'm going to hit next on this, next, and I'm going to add a tag. This time it is OD. So I'm going to hit next and create my auto-scaling group. So now we have two auto-scaling groups. One is completely on demand, one is completely spot, right? So let's see how we can add these auto-scaling groups as capacity providers into our ECS cluster. So I'm going to go to my ECS cluster that I just created. I'll click ECS Spot Demo, and I'll go to capacity providers. So if I will be adding it by hitting this create, and I'm just going to call this, let's say, CPSG on demand, and I'm going to select the auto scaling group that we just created. And here is where we enable that manage scaling setting, where ECS cluster will be managing your auto scaling groups for any scale in, scale out activities, right? And then in terms of target capacity, I'm going to set that to 100. What that means is this is the parameter based on which the scaling decisions will be made. When it is set to 100, what that means is you are telling ECS to utilize all of the resources that are available for your EC2 instances within that auto scaling group. We have customers who set that to 80%, meaning it only utilizes 80% of the EC2 resources that are available, and have 20% available for any immediate scaling needs that you might have. So I'm going to run this in the most optimal way. So I'm going to set that to 100. And I'll also enable manage termination protection. What this means is ECS will be aware of any ASG related activities that might happen, let's say availability zone rebalancing or things like that, which might terminate instances. ECS will be aware of it and make sure if there are any tasks running on those instances, it won't let it terminate. So I'm going to hit create. So now I have added the capacity provider. If I go back to my cluster, I can see another capacity provider right now. So I'm going to do the same for my spot capacity provider as well. This time spot, and I'm going to select the spot ASG, and I'm going to do the same settings that we just did for on demand as well. I'm going to hit create. So now if you go back to the capacity providers, we now have 4 different capacity providers that we can use to run our services. So you can have up to 6 different capacity providers in here, but how do we mention, or how do we control as to how many tasks of your service need to be run on each of these capacity providers? That's where the capacity provider strategy comes into place. So we're gonna hit this button to set a default strategy for this entire cluster. So I'm gonna click add provider, and I'm gonna add the capacity providers that we just added, right? And I'm gonna set the base to 2 and weights to 4. So what is this? What does this mean, right? If a service is using this particular strategy for deploying its tasks, what it makes sure is it'll run a base of 2 tasks on the on-demand instances or on-demand capacity provider. And from there on, any more tasks that it needs to run, it'll maintain a 1:4 ratio of on-demand and spot. That means for each task that is running on on-demand, it'll run 4 on spot. So this way you are utilizing spot and also maintaining a base of on-demand which can adhere or help you with any SLAs that you might have. So I'm gonna save that strategy here. And now we have all the clusters set up with the capacity providers that we have and also the strategy. So now let's look at task definitions, which is where you will configure all the specs that you need for your task. So I do have sample web applications here that I already set up as task definitions. Let's look at the EC2 task that I just created here. So if you go in there, so here is where you will define what all are the specs for your particular task, and also memory requirements and CPU, and also what are the different containers that needs to be run. In this example, we are running only one container. So if I expand that, so it is reading an image from the Amazon ECR service container registry, where I have my sample application build my Docker image and I pushed it into ECR. So that's the URL for the image. And in terms of port mapping, I have my container port at 80 and also host port set to 0. That means dynamically we are allocating host ports for this container. So that is a sample application that I have. Let's go ahead and create services around these tasks, right? So for that, I'm gonna go back to cluster and hit create service here. So we just defined our default strategy. I'm gonna use that for this service. And in terms of task definition, this is the task that I want to run as part of this service. So I'm gonna call this service, let's say web app EC2, since I'm running these on EC2. And let's say if we asked it to run, let's say 12 tasks, for example, right? So what else we are need to configure for the service? For the deployments, if you are updating the existing service, you need a strategy for your deployment so that there's no interruption, right? There are things like rolling update, which is what I'm going to use as a default, but you have blue-green deployment also, which is powered by code deploy if you want to use. And in terms of task placement strategy, you can ask to place your tasks so that the tasks are rebalanced or balanced across different AZs, or strategies like bin pack, which is what I'm going to use for this demo, will make sure that it is using least number of instances by memory and make sure that we are optimally using all the resources that we have and not wasting any of that. So I'm going to use that and go ahead and hit next. For this demo, I'm also going to be attaching a load balancer for my service. So I'm going to click load balancer. So I've already created a load balancer that I'm going to be using for this demo. And I will add a container to load balancer mapping that needs to happen so that the traffic is routed appropriately. So if you remember, the container port that we have is 80 and HTTP traffic. That is what I'm going to map to my target group, which I already have created, which is attached to my load balancer. So I'm going to do that. I'm going to hit next. So service auto scaling. So in terms of auto scaling for your infrastructure, you already have enabled that on your capacity provider. But for specifically your service, based on the traffic needs that you have, like spikes or anything, if you want to scale in, scale out your service, you can enable this option based on certain target tracking metrics that you have available from CloudWatch as well, right? So for this demo, I'm not going to be doing that. So I'm just going to say, do not adjust the service to the desired count. And then I'm going to hit next. So now that we are at this stage, I am going to go ahead and create the service here. So now, while the service is getting created, which will take a few seconds here, I'm going to go to my EC2 console, and I want to quickly show you how our auto-scaling groups looks like right now. So if I go to auto-scaling groups here, so if you see, since we attached this auto-scaling groups as a capacity providers, and if you see the automatic scaling settings, so ECS managed scaling has already actually attached a policy to maintain a parameter at 100. If you remember, that's the target capacity that we configured as to make sure that if any scale in scale out activities has to happen, that scaling policy will be taking care of all of that. So, and also if I go to CloudWatch to show the metric that is used for the scaling activity, let me quickly go to the CloudWatch and metrics, and under AWS ECS managed scaling, I should see that metric. And then these are the two capacity providers that I have. And I'm gonna change the resolution of this to 1 minute. And if you see this metric that is capacity provider reservation, it is right now at 100. Right, which is what the scaling policy also says, that it needs to be maintained at 100. What that means is this metric is calculated based on the number of pending tasks that need to be scheduled, and also the amount of resources that you have. So if this goes higher, what that means is we need to get more capacity from the capacity provider. So it needs to scale up. As you can see, since we just created a service, it went up to 200. So what that means is the managed scaling will know that it needs to get more capacity from the auto scaling group capacity providers that we just used. So, and also if you see the alarms here, right? So the target tracking for EC2 Spot went over 100. That's why it is scaling up. So let's go back to our cluster and say view service here. And as you can see, in the list of tasks, I can see all the 12 different tasks that I asked it to run. Few of them are already running, right? So if I go one level up to the cluster, I should see a tab called ECS instances here. That is where you will see the EC2 instances that came out of the capacity providers. As you can see, there are 4 instances that came out here. And there are 4 tasks that are running on one of the instances already, and other instances are up and coming, and for the tasks you are already running here. So let's go ahead and see our service if it is running or not. So I have my service load balancer URL here already, so I'm going to hit that URL. As you can see, it is a sample application. It just displays you what instance ID this traffic or the task that is running on, which is serving this traffic, and also the life cycle. As I keep refreshing, you can see different tasks are serving this traffic. You can see some are on demand, some are spot. So without any doing anything else or any service disruption, as the tasks are coming up, you are actually optimizing it for cost by running a portion of all of the tasks into on spot, and also be able to run that by using the strategy, right? So strategy that you used for this service is a lever that you can use based on your application. If you want to turn the knob and make it more cost effective, you can use more spot instances. So let's see, now that we saw how we can do that with EC2, let's see how we can do the same with Fargate as well. So I do have a task definition for Fargate task that I have, which is very similar to EC2, but this one in the specs, I do have a HTTPD image that I have, and I bootstrapped it by adding a sample HTML page that needs to show up as my sample service, right? So let's see and create a service for this one, which in this case will be running on Fargate. So I'm going to hit create here. So I'm not going to be using the default strategy, which is going to put that on the EC2. I'm going to do custom strategy for this service, and I'm going to add the Fargate capacity providers this time, right? And I'm going to say run to on the base, but for Fargate Spot, run more of my tasks on Spot, which is Fargate Spot option here. For the task definition, I'm going to select Fargate task, and for the service, I'm going to just do Fargate. And for the number of tasks, I'm going to still say 12 for this application too. I'm going to keep rest of the settings as is, but here I need to select what VPC I want the Fargate to be running as. I'm going to select the same VPC that we have been using all through, and I'm going to select the public subnets that I have. Let's see, one more public subnet. And in terms of security group, I want to use the existing security group that I have. I opened it, the port 80 to the whole world, just so we can hit the URL of this service. And I'm going to hit save. And I'll also enable public IP address auto assigning. So I'm not going to attach a load balancer for this example, but I'm just going to go ahead and create it. No service auto scaling as well. So I'm going to go ahead and create the service. So now, as you can see, with the Fargate, right, you don't have the additional responsibility of managing the infrastructure. It is completely serverless in terms of container. All you're telling is the task definition to tell what needs to be run on this specific task, right? So as you can see, the tasks are getting provisioned here. While they are provisioning, if you click on one of the tasks, it will tell you on what capacity provider this is running on. So this is Fargate Spot. And if I go back, let's say, as you can see, some of the services are already running. So I can see this is running on Fargate. The other is Fargate Spot, right? Let's go to one of the running ones and see if our application is running. So if I take the public IP address, since I opened it to the whole world, I should be able to hit that and see our sample application. So this is what I have in my sample application here. So as you can see, you can mix and match different options, different capacity providers, make use of Fargate to take out a little bit of heavy lifting of managing the infrastructure as well. And run your sample services as easy as this. That's all I have for the demo. Over to you, Preetham.
Thank you, Sandeep, for a nice demo. Okay. Again, screen changing time. Okay. Welcome to the world of Kubernetes. As you know, Amazon EKS is a fully managed Kubernetes service. Customers such as Intel, Snap, Intuit, Autodesk, they trust EKS because the scalability, the option that we can use Spot instances, and that EKS run upstream Kubernetes, which means that if you have already Kubernetes running in your platform, you can just move it to EKS without refactoring anything. And with EC2 Spot, we also have great integration with EKS, and we have got a cool integration coming with KOps, so that you can run your hyperscale Kubernetes pods cheaper actually. Whether you use open source Kubernetes or any kind of Kubernetes, or you use EKS, the underlying system remains same. So what is Kubernetes and what is EKS? EKS, you can say, an abstraction layer on top of K8, which makes life easier for you. So it gives you control node and the control plane and manage nodes, so that you can talk to different AWS services with easiness. You can have the integration, you can have the IAM integration, role-based access control, you can take care of the IAM policies, other features like connect to S3, different databases. It makes things easier for you. So whether you're running your own Kubernetes or EKS, the control planes remains kind of same. So if you have etcd server, the API server, and typically you don't have to worry about the control plane at all, because this is long running and this is most suitable for EC2 on-demand or reserve instances, or you can say savings plans kind of thing. If you're running EKS, then okay, you don't have to worry about that. You just pay $75 per month per cluster, and we take care of everything for you. So when you run an application, you typically would be considering the worker nodes of it, or worker plane, worker nodes, data node, what you may call it. So today, our whole focus would be on this part. So we'll be going through some examples today. So think about that. Our data node, it comprises of two different purchasing options, and I have got, let's say, 4 different node groups. So I have got 2 node groups which are from Spot, and 2 node groups which are from on-demand or reserve instances, what you can tell. And keep this in mind. So when you go through the examples and other things, will again fall back to this architecture. So when you run Kubernetes or K8 in short, mind the question why you call it K8, because the 8 digit between K and S. So we have to think about primarily 4 different things: how you get the capacity, how you scale them, and how you make Kubernetes work better using different kind of Kubernetes implementation like tail toleration affinities, and how we handle interruptions. And then we'll talk about some tools and technologies that can help you. If you are new with Kubernetes or you have pro in Kubernetes, these slides will be helping you to make things more spicier actually. So when you need capacity, let's say you talk about EC2 boxes, again, you have got lots of options to choose from, like 300 plus options. We make things easier for you by giving you a tool called EC2 Instance Selector, where you can download the tool from GitHub. You can implement this thing as a Go library in your code, or you can use it as a standalone application in your computer or your Mac. So what it does when you run it, it will give you some kind of option like run EC2 Instance Selector, what kind of memory you want, how much VCP you want, and give the region, CPU architecture. It gives you a list of instances you can run actually. These are primarily important because your worker nodes, your whole worker planes will be running on top of this. We'll come back to this list again and again in our demo today, why this list is so important. Otherwise, if you just want to see it in a table-wide view, you can just query the thing with a table-wide view, and you can find out about the hypervisor type, if you want to have something Intel or AMD or some kind of different CPU processor, if you want to know about the network performance like slow, high, or moderate, or you want something 100 gigabits at least. So you can query by that, right? So this will be useful for you to get the instances you need for your Kubernetes nodes. Now the most important thing, how you scale, because without auto scaling, life is difficult, right? Our DevOps engineers, our SRE engineers has been holding the fort until now to do the right sizing. When it comes to containers, especially Kubernetes, you don't have to do the right sizing all the time of your own. So for Kubernetes, there are 2 primary things: the pods, which are the atomic level, and then the nodes. Nodes are nothing but you can say the servers or the instances or the VMs, whereas pod are the combination of containers. Now there are 2 kinds of scaling: horizontal and vertical. For sake of simplicity, we won't talk about the vertical scaling as of now. It is very, very, very like new at this moment. We'll only talk about the horizontal scaling today. So think about if you want to scale the node, we have something called cluster autoscaler. If you want to scale the pods, we have something called horizontal pod autoscaler. Now, how HPA works? It's typically very easy to see that, let's say I have got my pods running, I've got my 4 pods running, and then I have put a target, like I put a target at like 70%, let's say. And I'm saying if my pod pod is utilizing more than 70%, then I think we need more pods. So you install a HPA daemon set and then put a number there, let's say 70. And then if your pods are utilizing more, then it will ask for new pods to be created. Actually, HPA works that simple. So we keep a buffer. So why don't we keep it 90% or 100%? That means if it's already reaching 100%, you're already constrained, right? So by the time new pod comes, you need more capacity that you don't have. So you give some timing buffer actually, so that until a new pod comes and takes the traffic, because traffic typically will be routed to load balancer, and load balancer takes some bit of time to understand the new pods, right? The ingress controller and all. So in that case, we keep in buffer. 70% is like good amount of setting actually, like nice setting, where you get a nice buffer to work around. So HPA will do that for you automatically. You don't have to worry about that. Now, let's say in this example, my HPA needs some 2 pods to be scheduled. But now one pod needs, let's say, 4 vCPU, one pod needs 3 vCPU. Now I have got 2 node groups, node 1 and node 2. We'll come back here in a second. So now what I see, I cannot schedule my pods on any of them, right? Because I don't have the capacity left. I got only 2, 2, 2, 1 left. And this cannot be broken, right? Because this is the least atomic like size of it, right? So that means I need new boxes here, or I need new boxes here. That's when actually your cluster autoscaler comes into picture. So cluster autoscaler polls every 10 seconds or 30 seconds. So you can set it up. And when it happens, cluster autoscaler understand that I need to give you more nodes or more boxes. So this pending pods from here now got a home here actually. So this cluster autoscaler created 2 new nodes like this, and your pods are now sitting here. Now you can say, why my pods got in this node group, not on this node group? Okay, we'll come back to later. So how you control which node group actually will be used first. So what you got here, so you can automatically adjust the size of node groups. This typically on the AWS side, this is nothing but autoscaling group. On Kubernetes side is nothing but node groups. So it automatically adjusts the size of node group, and it scale up when pod failed to schedule due to insufficient capacity. So it checks for every 10 seconds if there is no space left. So it creates new nodes for you. And same as like that, if you are over, there is no need for the new pod, there is no pods running, and there is a box with empty, like there's a box with empty pods, then it will scale down the pod. It will cut the box after 10 minutes. So things are simpler for you, right? You don't have, so if you use horizontal pod autoscaler, if you use cluster autoscaler, that means you don't have to worry about anything. You just set up the limits and bingo, you just pods come and go, nodes come and go, your application is up and running. But this cluster autoscaler has got some limitations. So think about this when you use Spot instances or any instance types, like on AWS cloud, you have got lots of instance types, right? Now you can have different kind of requirement in your application. You can have requirement for GPU based need. You can have CPU based need. You can have needs for your big data application, whether you run your Spark cluster, right? So one size doesn't fit all. In that case, what you'll do, because one size doesn't fit all, that means you may have different node groups. Now this cluster autoscaler expects that inside a node group, all the instances will be homogeneous. That means they should have same vCPU and same RAM, and which is kind of breaks the diversification, what you call with Spot, right? So think about this. I have got 4 node groups here. These are the node groups I have here, right? Now I have created these 4 node groups like this. Now they expect that everything in this node group should have same capacity. And so I'll just come back to this question now. So go back to earlier question here, how we define how you either this go to this node group or this node group, right? So as example, I have got 4 node groups. Now we decide if it will, so with name 4 vCPU 16GB spot, 4 vCPU 16GB on demand, and then higher size 8 vCPU 32GB spot and on demand. So I've got 2 spot nodes and 2 on demand nodes. Now how you see where it should go first, right? Here comes the expander. So if you see this little one and the grayed out box, so if you say expander has got 5 kind of expanders actually on autoscaler. We typically use the priority expander. What it does, you write a config map for your Kubernetes and you say that define my priorities. Now you do a regular expression based on priority. Higher the priority, higher is the preference. So it is like 200, the 20 has got higher preference than 10. And I am saying any node group that has got this name has got the higher preferences. That means out of these 4 node groups, I'll try to fit in from these 2 first. Okay. And then I'll try to fit in. Then if I don't get my nodes from these 2 node groups, then I will go to the other one. Now I'm just giving you an example of on-demand and spot. It can be anything. It can be GPU, and it can be CPU based. So let's say you have got a workload that needs GPU first, but if you don't get a GPU, then you fall back to the CPU instances. You can do that. So I created 2 node groups for, let's say, GPU and 2 node groups for CPU based or spot or on demand. So you can play with this. You can play with lots of different options. If you have a choice of instance types, you can work on that. By default, this takes 15 minutes time to, it will load for 15 minutes if you don't get a capacity from these node groups, and then Kubernetes will go to other node groups, but you can change this fly actually. So typically we have seen 5 minutes is a good time to set it the provisioning time. If you don't do it, the default will be 15 minutes. This is like very, very important after we introduce this to our customers. We've got a raving review actually that how easy it is to implement. Now coming back to the earlier point, that Kubernetes autoscaler expect all the boxes to have same size. How you do it, right? So in this node group, what I am doing, I am putting different boxes. So if you see these boxes, this 1, 2, 3, 4, 5, 7 boxes we have. All 7 boxes has got same size, right? They all has got similar 4 vCPU and 16 GB RAM. Now when Kubernetes comes and get capacity from this node group for Kubernetes, though they are from different kind of family and different instances, for it has got the same size, right? So it works perfectly well in this case. Now, for this node group, the spot node group, what I am doing, I am keeping the base on demand as 0, and after base also on demand 0. That means it is fully spot node. So anything I get from this node will be spot. And also I am using allocation strategy as capacity optimized. And one more important thing, how Kubernetes will know this is how I'll tell my application to run on spot node, run on demand node, or run on GPU or CPU node. So what I'm doing, I am putting a label called lifecycle EC2 Spot. So that means anything that comes within this node group, I'll mark this as EC2 Spot. And also I am giving intent as application. So you can have lots of other intent actually. And for this on-demand one, you can put is like on-demand. Okay, so those options we have. So with Kubernetes, you can play with lots of options. So what I'm doing, I'm creating 4 node groups, 2 for spot of different sizes, 2 for on-demand, different sizes. Now, if you go back to this example, you know why I created this node groups, right? It's of 4 CPU, it has 4 CPU, it's got 8 CPU, got 8 CPU. So now if my Kubernetes wants some capacity, so I know this anything I get from this node group will be having all 4 cores, all 4 cores, all 8 cores, all 8 cores, and these are homogeneous inside this. So I solved this problem, the cluster autoscaler problem what we have. Now with Spot, as some of you may be knowing, we have got two options. The Spot strategy, we can have lowest price. That means I can say, give me lowest price instances from the pool. So I have got 3 instances in the pool. In my example before, I have got 7 instances. To keep it simple, I have given 3. So it will check in each availability zone. It will check for the cheapest price. So here I got R4 and M4. I got R4, R5 and M4. For here I get M5 and R5. Here M5 and M4. Now this is one option. The better option or the suggested option would be you go with something called capacity optimized. What happens here? We typically actually at AWS end, we typically look for the deepest capacity from these overrides in each availability zone, and we give you instances from there, which means your interruption will be less, much less, right? So from here I get R5, from here I get deepest pool M4, from here deepest pool M5. So it is like allocation strategy, a single line change actually, by which you can make the optimized allocation for your Spot. Now, next question is that you may not want to run all of your pods on Spot or even or vice versa, right? So think about the lifecycle policy I told you, not policy, lifecycle tag I told you earlier. So you can have a preference actually. You can have a matching expression, and at pod level, you can have this expression or service level actually. You can say that I just want to run with the affinity, node affinity on only on demand. So some of the pods you can choose to run only on demand, or some of the pods you can run to choose on EC2 Spot actually. That is like very easy. If you use affinities, toleration, and tens, within this combination, you get lots of options to play around here, and you can exactly tell where you wanna run your instance, run your pods on demand, or which kind of instance type, GPU type, CPU type, C type, M type, whatever you wanna do, right? So there are unlimited options we have got. If you want to learn more about this, we have got some excellent resources here. We have got lots of a lab document, sample codes in our GitHub repo. So at the end of this presentation, we'll be getting all the resources as I'm talking through. Now, as you know, Spot is an interruptible service. An interruption can happen. On an average, it happens 5%, but depending on the instance types, it may be lower, it may be higher. But do you need to worry about that? No. Because we have something for you, which you call node termination handler. You can see that at GitHub, download it, it runs a daemon set. So using HPA and cluster autoscaler, we also recommend that you use the node termination handler. So what it does, it sits on your nodes. It can sit on your Spot node, on even on-demand node, doesn't matter. What it does, whenever you got a Spot termination notice, it gives you 2 minutes or 120 seconds. This runs every 5 seconds, so that at 115 seconds to spare, you get a notice that this Spot box, one of the Spot box, is going to be terminated, right? What it does, as you get a notification, it gets from instance metadata actually. It taints the box or node. It says, okay, boss, this is going away. Let's not create any new pod in this node. So it prevents this node to host any new pods. Then it also says your ingress controller, egress controller, and other your cluster autoscaler, your horizontal autoscaler, that I am draining the containers from this node. So let's say I have got 5 containers, 5 pods. I'll start to drain them one by one. Okay. Now these 5 pods, what I have drained from this node, tented nodes, has to be scheduled somewhere. Then your HPA comes into picture. Your HPA says, okay, I get to schedule this five pods somewhere. Let's find a new box where I have space. If you have a space left, fine, that will schedule the pods there. But what if it doesn't have a space? Then it will call the cluster autoscaler. It will tell the cluster autoscaler, see, I have 5 pending pods and I don't have space, then give me new boxes. The cluster autoscaler will give new boxes where these pods can come. It happens like automatically for you. You don't have to worry about these things. So node permission handler, HPA, cluster autoscaler works like hand in gloves actually. Now, it may happen that everything is working fine and replacing instances all happening fine, and you get nothing to worry about, right? So if you see using these 3 options, you can just get rid of any problems that you have. Your system will be up and running. If one node goes away, it will create another node from a different instance type, whatever the allocation strategy you have given. So you can expect a high availability for your application. Okay. So that being said, I'll go to the tool section. I'll not talk about the tool section today. I'll just skip it forward. So you have got lots of other tools like CloudWatch, Content Insight, the scheduler, pod priority. So I want to talk about the pod priority actually. So coming to this one, now this cluster autoscaler will take some time, like let's say 3 minutes, 3 minutes to start this box. But if your application cannot wait for 3 minutes, what will do? So in that time, you can keep some space here on your existing boxes. Is this reserved as called low priority pod? So low priority pod you can have in pod configuration. That means this is just a stakeholder, or you can say this low priority pod just keep the space reserved. And if you have some eviction like this and your pods, which will be calling high priority pods, need some space to accommodate, then it will evict these low priority pods and go and sit there. That means you have always some kind of buffer actually in place with low priority pods. And then it will give some time to your cluster autoscaler. So you are not out of capacity. So that's another option you have actually, right? So I'll pause here. So if you have any question, you can just put in the chat, and also you'll be answering questions at the later point of time. So what I'll do, I'll go and show you a demo. So because EKS or Kubernetes demo setup take lots of time actually. So what I'll do, I have a whole setup up and running. The setup looks like this actually. I have got a EKS cluster running with an on-demand node group, and I have also scheduled 2 Spot node groups. Currently, there are no app running, so these node groups are not active. But when I intend to run a Monte Carlo application on the Spot, then these node groups will come into picture. So for this lab, you can also do the lab on your free time actually. So you need to install. So I am using Cloud9 environment, which is like CLI environment. You can run on your Mac or Windows using wherever like Docker is installed or EKS-Cuttle or kubectl is installed. So I have installed Kubernetes tools. I'm using EKS-Cuttle. I have also created a cluster as EKS cluster. I've also used Helm charts to give some metrics, metric server and a QBox view. And I have got Spot nodes. And now I have deployed a microservice in there. And then I have also deployed a horizontal pod autoscaler and cluster autoscaler. And we'll see how it works, okay? Okay. So coming here, so coming to my EKS, this is EKS cluster. If you come and see, this is a AWS able to see my screen still, right? Okay, so this is my EKS cluster. In here, I have got a EKS cluster. So go to cluster page. You see the EKS cluster here, and here I have got a small cluster running using. So I have got a managed node, which is a managed node running on demand of size 2. So it's a environment where I have got my system ready. So I have got this QoS view where if you see this is a cluster and I've got 2 nodes here actually. If you the small, okay, make it larger. If I hover around, if you see there'll be small life cycle like on demand. These 2 nodes are on demand. I am also running a Monte Carlo application here, which is not running anything right now. So what I'll do, I'll go and run my Monte Carlo application, which should be running on Spot nodes. So now I don't have a Spot node running right in this cluster. I go here and say, give me 3 replicas of Monte Carlo actually. And then what I'll go and see. So I got 3 pods coming up. Now these pods are in like pending state because they don't have a space to run, space to sit, right? And I have also said this pod to run on Spot nodes. Now these 2 nodes are on-demand nodes, so they cannot be scheduled on-demand nodes. So now my cluster autoscaler would be getting me some pods, some nodes actually. If I go here and say get pods, we'll be seeing these 3 pods are pending state, right? So they have no space to run. So what I'll see here, it will give me some box quickly. So now my cluster autoscaler is working. It will take some time to get the new boxes. As soon as we get the new boxes, these scheduled pods will be getting on them. So if I come to my ECS instances, you'll be seeing some new boxes should be coming up actually. So right now, you see this boxes is, I think, yeah, this box, if you see the last box, launch time, okay, happening. Yeah. So this new instance came up, which is a Spot node of 4 vCPU 16 GB. It just started. If you see here, the time is 11:41 now. If I come here, let's see, the new box came up, right? With a tag of lifecycle EC2 Spot. And if you see, it's got a M4 X large box. Now, as the box gets ready, these 3 pods will be scheduled in the here. So the below are the system pods actually. And these pods are Monte Carlo pods. The application that I am running will come and schedule here. So you can see how much CPU utilization, how much memory utilization we have here, and then see the pods are up and running. So now I can also use HPA and show you that. But I'll skip that part because I think I don't have time left. So I'll save some time for the Kahoot quiz and also for the question and answer. So you saw, right, how easily we can schedule the pods on my choice of boxes. So I'll give the link of the lab, how you can go and schedule, do the whole lab and do lots of fun stuff actually. With this, I'll hand over to Sandeep, who will do the Kahoot quiz. What I'll also say, because the Kahoot quiz, you need to play and you need to see the screen also. So play the quiz on your screen, actually. So we'll be giving you some QR code that you can scan and you can see, you can scan it and play the quiz on your phone and see the questions on the screen. With that, I'll hand over to Sandeep.
Very exciting. Glad to see so many people participate and give answers. So we have about 6 minutes left, and we'll now just open it up for live Q&A if anybody has any questions. I think we did get to all of your questions in the chat window. If there is anything remaining, please feel free to ask.
Do you have any plans of supporting GPU on a Fargate?
Pritam, are you on mute?
Okay, so we have got a container roadmap actually, and I am sure that question is there already. So if you have if you think that is right thing for you, why don't you go ahead in the container roadmap? The link I'll be sharing again here, if not shared already, and plus one that. So and we can also see what state that has, like they're working on that or they're still exploring that. So I don't have the exact information about the current state, but I'm sure we have a GitHub issue open in a container roadmap page.
Even with the Fargate, like you have maximum CPU to 4. And like if you have like an application which requires more cores, and like we don't have an option there. And moreover, one thing is like even you mentioned like number of vCPUs as 4. But we don't know what is the speed of the CPU. What kind of CPU is it, or is it totally abstracted, or like what? Because I normally see like if I run an EC2 based ECS, like it's much faster. Maybe I'm using compute optimized for my application, but compared to the Fargate, and like, is there any way we can specify that, or like is there that you have in the roadmap?
The answer is no, you cannot specify that. So I can tell you that each Fargate task runs on separate EC2 containers. Okay.
Yeah.
Unless we have this firecracker in place. So and that what we do, we typically see how much you need. So you specify a RAM and a memory, right? So based on the kind of RAM and memory ratio you need, let's say you define one vCPU core and 8 GB RAM, that is applicable for R type, right? Or 1:2 is for C type. So based on your need, actually, we give you the instance types. What kind of instance types will be allocating to you? What generation? We don't have a visibility into it actually.
Okay. And so, normally the Fargate instance launch time typically takes around 30 seconds, which I have noticed. So that is that any chance of improving that, or like because that where we have that's actually adds up a latency for a microservice thing, because like if my processing itself is take 30 seconds, this guy adds 30 seconds more, delays me a minute.
Okay, yeah, that's like a good question there. So we are always working on to improve that. So right now what we do, we keep a pool actually. We keep a pool of Fargates ready to available for you to get things done. Now, as we see, we are working on the firecracker of the part of the things. So you should be seeing something improved actually. But again, if you see the latency is something that you are seeing consistently, why don't you send us an email and we can connect you to the right people actually.
All right. Amin has a question. Amin, do you just want to ask it here?
Yes, sorry, I was on mute. So no, I was just adding on to the existing question. Why do you have 4 max? So my understanding was it was, as you mentioned, it is to keep it homogeneous or something like that, and then it scales horizontally.
For your Kubernetes node groups?
Yeah.
No, you can just 4 is the number what I put. You can have more than 4 actually. You can have 10, 20 also, not a problem.
vCPU, is it?
Okay, vCPU should be same in a node group because Kubernetes autoscaler works based on the history actually. So if it gets a box which is like 4 vCPU 16 GB, it will think that other boxes will be having same kind of infrastructure, right? So that's why we try to keep it same. You can have a C type like 1:2 ratio. You can have a small boxes also, but try to keep all the boxes of same size inside a node group.
Right. Is there a way that we can only specify, so this is the number of CPUs we want, and just scale based on just maintain that capacity and don't specify the family type?
See, family type based on the generation. Okay, no. If you don't see the family type, right now it only understand via the full name, like family, generation, and size, right? And if you don't give a family, then C type has got 1:2, M type got 1:4, our type has got 1:8 ratio, right? So it is like a different ratio for all different families in the same size.
Yeah, fine. Good. Thanks.
Thank you.
All right, we are out of time. So Pritam or Sandeep, why don't you go through the rest of the slides and then we'll wrap it up. We'll take 2 more minutes.
Yeah, so one more thing before we go to the slide, we'll be sharing the slide with you. We'll be sending a mail to you in like 1 hour or something with a survey link. So you can also scan the survey link here and give us quick survey. So Aparajita, me and Sandeep, and recording, yeah, we have a process we are recording the session. After the end of 3 sessions, we'll put the YouTube links after you do the calibration and etc. Okay, so the decks will be shared in the thank you mail that we'll be sending in some time with the survey link. If you want to give the survey now or feedback, you can scan this code. So at the end of the presentation, we have got lots of references and the slides we cannot go through. Please have a look into it.